Okay, so here we're going to do electrolysis. Now, electrolysis is a process for splitting up ionic compounds. So it works if it's an ionic compound. So it needs positive charges and negative charges. It needs ions. It will only work if the ionic compound is molten or dissolved in water, i.e. a solution, so aqueous. And the reason for that is the charges need to move, okay? And in a solid ionic compound, for example, salt, the charges don't move, so it can't conduct electricity. So therefore, when they're molten, this is an important point, the ions are free to move. And therefore, if they're free to move, they can conduct. So we're going to do this example with molten lead bromide. So we've melted lead bromide. Now it is ionic, and the lead has a positive 1+ charge, and the bromine has a negative charge. And we call the thing that we're trying to break up the electrolyte. So lead bromide is our electrolyte, and we've got a battery attached. So by using the battery, if we pass an electric current through the electrolyte, it causes the ions to move. Now on either side of the battery, we have what we call our electrodes. So we've got two here. We have a negative electrode next to the negative charge and a positive electrode. And we actually give these more specific names. And the way I remember these names is with the mnemonic panic. So panic stands for positive anode, negative is cathode. So the positive one here, positive electrode, is called the anode, and the negative electrode is called the cathode. So that's everything we need to know. So at the start, we have positive lead ions in the solution, or molten, so they're free to move. And we have negative bromine ions, free to move. Now, as soon as we turn on the battery and the electric current goes through the electrolyte, these molten lead bromide, the charges move. Now, because this here is negative, it's the negative cathode, positives will be attracted to it because opposite charges attract. So the positive lead will move towards the negative. The positive charges will all move to the negative, and the negative charges will all move to the positive. So the key idea here is that opposite charges attract. So if I leave my electrolysis working, the electric current going through my electrolyte, I'll eventually get to this point here, where the positive bromide ions, have gone towards the cathode, and the negative bromide ions have gone to the anode. Now what happens here is the ions are discharged, okay? So that means they lose their charge. So what's going to happen to the lead? Well, the Pb ions will gain an electron, and you will get pure lead. That's your product. On the anode, the bromine ions will lose an electron, and they will form bromine. So you'll get pure bromine being formed here. So, if we go back to the very idea of electrolysis, we started with lead bromide, an ionic compound. And what we've managed to do is, using electricity, we've split them into pure lead and pure bromine. We've done it using electricity, using their different charges. Now, if you can link this to other ideas and know that gaining electrons and losing electrons has another name, well then that's fantastic. We use the mnemonic oil rig. So oxidation is loss, reduction is gain of electrons. So the bromine is being oxidized and the lead has been reduced using this mnemonic.